So first of all with this, we've got to derive twice, but we are going to, I'm going to say that f dash of x, and I'm going to do the chain rule in my head, and you don't have to, of course, do, what I'm doing is I'm letting u equal 2x. And the chain rule states that dy dx equals dy du times du dx. Du dx, the derivative of u, in other words, with respect to x, is going to be 2. Then I'm going to say that u is 2x, and of course, straight from my formula sheet, the derivative of that would be 1 on 1 plus u squared. Now, u squared is 2x all squared. So that's going to be, so can you see there that you can derive just pretty quickly as long as you're applying the chain rule correctly. Otherwise, we are letting you, you're doing it the long way. Let u equal 2x. Du dx is equal to 2. Y, or f of, f of x is equal to some function of u, but I'm going to say that y equals inverse tan of u, and dy du is equal to 1 on 1 plus u squared, and therefore we can say we're then multiplying those like so. Now, I eventually want you guys to just be able to do that in one step. But I tell you now that half this class, come end of year and come exams, I can guarantee you when we sort of do kinematics and mechanics, we'll sort of forget to, you'll just omit this 2 for some reason because you're not applying that properly. Now, we want to, of course, derive that. Now, of course, probably we could do it 2 ways. We could do it using the quotient rule, or we could do it using the product rule. Now, I don't know, personal preference, I just prefer to stay away from the quotient rule sometimes when I can. So how I derive it is we can say that f dash of x is equal to 2 times 1 plus 4x squared to the power of negative 1. And of course, I'm going to just derive it like so. But really, that's not really a product rule question. So we can just derive using the chain rule, if you like, with this one. So derivative of, I'm letting u equal 1 plus 4x squared. What's the derivative of 4x squared? 8x. 8x comes out the front. So f double dash of x, so we don't need the quotient rule at all for this one, do we? Because 2 is not a function as such, just a constant. F double dash of x is equal to, we've got the 8x out the front, times 2, and we're dropping that power by 1, aren't we? So essentially we've got this, 1 plus 4x squared to the power of 2. All right, now we've got f double dash of x now. Now we want f double dash to the pi on 2. So that is going to be 16 times pi on 2. That's going to be 8 pi over 1 plus, be careful though, 1 plus pi on 2 squared. So that's pi squared on 4. So that's 1 plus pi squared squared. Is that what some of us got? Yeah? Good. Well, that's the correct answer. Now let's have a look, and I might just pause this here. Now I've just discussed that, and there you go. 4.5 minutes is how long it should have taken you at the most. And some of us at 5 minutes was maybe halfway there, so we've still got a way to go. Personally, once you get pretty quick at this, I reckon most of you could do this in about 3 minutes. if you're applying the chain rule correctly and stuff. I'd prefer you to do it the long way, as I said, if you're getting it wrong. So I'm just going to pause it there. Well, so here we go. This is how I would do it. Now, you do, if once you know what you're doing, you can do this in a pretty quickly without skipping any steps. The main thing is we get the answer right. So, what I would do if I was one of those students prone to making mistakes and forgetting the chain rule is I'm going to let u equal a half x plus 1, especially with this something like this. Du dx is equal to a half, and y equals 2 on pi inverse sine u minus 3. Thanks, guys. Shh. dy du, of course. Now remember that 2 on pi doesn't go anywhere. That's a constant out the front. So the derivative of inverse sine of u is what? Is it negative or positive? Positive. So we've got 2 on pi square root of 1 minus u squared. And u is a half x plus 1. So it's going to look like this. 1 minus a half x plus 1 all squared. Like so. That's, of course, me filling in and putting u in. Now, that du dx of a half, that's going to apply across. So therefore, we can say that f dash of x is equal to 1 over pi, like so. Half x plus 1 all squared. It's not in the form that we want though, is it? So what I'm going to do is I'm going to expand that out, and we can work out where we go from there. So that's going to give me 1 minus 1/4 x squared plus a half x plus a half x is x. But be careful because there's a minus there. So minus x minus 1. Aha! Look at that. Because those ones are going to cancel out. And I've got this. Now, I can take out x as a common... I'm going to take out negative as a common factor. Negative x as a common factor. And therefore, we can say that that is 1 plus... And I might take out a quarter. I might take out a quarter as a common factor as well. So that is 4 plus x. Good. And the square root, that means that I can take out that 4 out the front. That's a fraction. So what I can essentially do is that's going to be over 2. And what's going to happen? That 2 is going to... That's going to go over there, isn't it? So I've skipped a couple of steps there. Now, now is that in the format we want? BC, yep, that's it. So therefore we can say that A is equal to 2, B is equal to -1, and C is equal to 4. Yeah? Awesome. Now let's have a look at the examiner report. So, just quickly, this was the answers. The domain was -4 to 0 inclusive, and I'll sort of go through and discuss that when You have? Yeah. The range -4 to -2, and of course for part B, there you go. As you can see though, 56% of students got between 0 or got either 0 or 1 mark. So they lost, over half the cohort lost 2 out of the 3 marks in that question. So you can see there that it wasn't done very well. Only 34% of students got just the basic domain and range question, which I guess, so in my case, I'll pause the video there.